Good day, viewers. In this video tutorial, I'm going to teach you in less than 10 minutes partial differentiation. And looking at the question they give us here, they said if z, a function z, is equals to 4x squared plus 3xy minus 2y squared, we should find I, second derivative of z in respect to x, second derivative second partial derivative of z in respect to what? X, second partial derivative of what? Z in respect to y, and as well in respect to z. Then coming to this, we said second derivative of what? Z in respect to what? Y. IV, second derivative of what? Z in respect to what? X and in respect to y. That's what the question is all about. Then let's just look at this in less than 10 minutes. I'm going to what? Clear you in terms of partial fraction here. But remember, if you have not subscribed to my channel, endeavor to subscribe to enable me grow the channel. Like and share to your friends. Thank you for doing that. Then what do we call partial differentiation? We apply partial differentiation when we have a function depending on two or more things. When a function, look at the z, depending on two or more things. For instance, if I say area of a rectangle is equals to length times what? Breadth, length times height, or breadth, or as case may be. That means that area depends on the length as well, depends on what? Height. So if I want to get change in area, I have to differentiate this area in respect to what? Length first, keeping the height constant. And as well, differentiating this area in respect to what? Height, keeping the what? Length constant. That's what it means. Partial differentiation means that this area depends on two things. And as it depends on two things, which is two functions, so that as the length is increasing, width also increasing, it affects what? The area. Therefore, if I want to get a change in area, it means that area depends on the length as well depends on the height. For instance, we know of what? Internal energy of a fluid or a substance is a function of what? Temperature and what? Volume. That means that internal energy of a substance depends on temperature of that substance and the volume of what? That substance. That's internal energy. The energy content of my body depends on my volume and also my what? Temperature. So that means that this internal energy depends on temperature and volume. So if I'm going to have a change in my what? My body, if I want to help a change in my system, look at my body as a system, that means I have to differentiate internal energy in respect to what? Temperature, keeping volume constant, and also differentiating the internal energy with respect to V, keeping temperature constant. And that's what we call partial differentiation. Let's go to what they gave us. I have given you an include of what we call partial differentiation. Then now, let's go to the first question. The first question said that we should get, look at it, we should get second derivative of what? Second partial derivative of what? Function z in respect to x. And this means I should get derivative of function z first in respect to x, and I'm going to differentiate it again, partial differentiation again, after I have gotten that. And this means the same thing as x. So the partial differentiation of z in respect to x, that's what I'm going to get first. After I have gotten it, I have to differentiate it again. I have to partially differentiate it again in respect to x again. I have partial differentiating function z in respect to x, keeping any other value that is not contain x to be constant. Get me right. As I'm differentiating this function z in respect to x, I'm keeping other item, other things that is there that does not contain x to be what? Constant. And you remember, when we differentiate constant, we have what? 0. What does it mean? If I'm saying I'm differentiating z in respect to x, it means that I'm keeping any other thing that does not contain x to be what? Constant. And if I differentiate it, it will give me what? 0. Then I have this. And z, function of z is 4x squared plus 3xy minus 2y. I've got in there in respect to what? X. I'm differentiating in respect to x. Then I'm going to do what? Differentiate this 4x squared separate in respect to x plus, look at my plus. Look at my plus here. Differentiating 3xy in respect to what? X minus, look at this. Differentiating what? 2y squared in respect to x. Then coming over here, differentiating this man, I have to use these two to multiply for giving me what? 8. Subtract 1 from it, that's differentiation. That give me what? 1. That means x raised to the power 1 is x. Plus, look at my plus here. Differentiating this man, despite that this man is there, but he has x, therefore he survived. Why do I survive here? Because it contains x. That's why the reason why this y will survive. It contains what? X. So the person I'm going to deal with here is only x that I'm going to differentiate, because I'm differentiating in respect to x. And this x now become a constant. And I mean to say, this y now here become a constant. And since it's a constant and it contains x, it will survive this differentiation. Get me right? I'm differentiating 3xy in respect to x. Means that what? Any other thing that doesn't contain x is a constant. But this y here, which other things? He contains x, therefore he is going to survive the differentiation. And looking at here, what I'm going to differentiate here is only the x. I'm differentiating only the x. Why the y is a constant, and 3 here is also what? A constant. 3y is surviving because they contain what? X. So now differentiating this x, I will have 1. And you know what I'm dealing with now, dx, and what we have is what? 1. And when I differentiate this x in respect to what? X, I'll have 1. 1 times 3 is 3. And 3 times y will give me 3y. And that's what we have here. Then getting to this place. I'm differentiating 2y squared in respect to x. You see that this y squared does not contain x. If I differentiate it right now, I will have 0 because it's a constant. Because I'm dealing with z, the function of z in respect to x. Therefore, this y does not contain, y squared does not contain x. And if I differentiate it, it becomes what? 0. And as it becomes 0, I will have 8x plus 3y. Therefore, my dz dx is equals to 8x plus 3y. That's my dz dx. That's my differentiating the function z in respect to x. That's first derivative. Then let us go to second derivative of that. I'm going to have this. This is my second derivative of what? Z in respect to x. Therefore, I have gotten the first derivative. What's the answer of the first derivative? Look at here. The answer of the first derivative is what? 8x plus what? 3y. I'm going to differentiate this answer again. I'm going to partially differentiate this answer again. Then I will have 8x plus y in respect to x again. Are you get what I'm saying now? This 2, x raised to the power 2 mean in respect to x 2 times. So now, differentiating this man, I have differentiated the first one in respect to x, the first one. Then I'm going to differentiate what I have as my answer in respect to x again. Look at it. Then differentiating 8x separate in respect to x. Differentiating 3y in respect to x. I have this in respect to x plus, look at the plus here. Differentiating 3y in respect to x, I have it here. Then what am I doing? You remember what I'm doing here? I'm differentiating this function in respect to x. Therefore, anything that doesn't contain x is going to be a constant. If I differentiate, it becomes 0. So differentiating 8x in respect to x, I'm going to have 8 plus, look at my plus. Differentiating 3y in respect to x. You see that I'm dealing this function in respect to what? X. Therefore, this man does not contain x. If I differentiate it, it's going to give me 0. Are you get what I'm saying now? Because the war is declared onto what? X. When I say When I say dz dx means I'm declaring war onto this function z. And the only people that will survive this war is the people that contain x. Okay? Are you getting what I'm talking about? I said, when I said d partial differentiation of z in respect to partial differentiation of what? X, means that I'm declaring war onto the function z. And it's only people that contain x that will survive that war. Then if you did contain x, if I differentiate you, you're going to be 0. That makes you are a constant. Immediately you didn't contain x, it means that you are a constant. When I differentiate you, become 0. Therefore, I'm saying dz in respect to x means I'm declaring war onto this function. And any pole that doesn't contain x will become what? 0. And this man does not contain x, and differentiate it, it becomes 0. Then differentiating 8x will give me what? 8. Therefore, my second partial derivative of z in respect to what? X is equals to what? 8. And that's the answer for the first question. Okay, and somebody may ask, how do we get this to be 8? You remember that our differentiation, that this 8 is 8x raised to power 1 is what we are having here. And differentiating this, I will take this one to multiply 8 and the s, then 1 minus 1, and this will give me 8 into what? X raised to power 0. And anything raised to power 0 is 1, and x 8 times 1 will give me what? 8. That's how we get this. Are you get what I'm saying? You remember our differentiation that y equals to what? X raised to power n. Therefore, dy dx is equals to dx raised to power n all over dx, and that give me what? N times what? X raised to power n minus 1. And that's the format. Question number 2. Second derivative of z. That's the partial second derivative of z in respect to y and respect to x. This means I should get what we call differentiation of z, partial differentiation of z in respect to what? X. After I have gotten that, I have to differentiate my results in respect to y. What does it mean? It means I should get differentiation of z in respect to what? X. Partial differentiation of z in respect to x. After I have gotten that, the value I have as my answer, I have to differentiate it again in respect to y. Look at it. Differentiating z in respect to x, after that, you now differentiate the results in respect to z. Then I now say but. Look at it. But the differentiation of z in respect to x, which we have done before, is what? 8x plus 3y. We have differentiated this function in respect to x before, and we have 8x plus 3y. That means that this function is already what? This change is already 8x plus what? 3y. Taking this as this, putting in this, I have that my this will give me partial differentiation of 8x plus 3y in respect to y. Now, I'm differentiating it in respect to y. The first one, I differentiate z in respect to x. Differentiating z in respect to x, we have it as what? 8x plus 3y before. Then after I've done that, I'm going to retake the result, differentiate it in respect to what? Y. I'm partial differentiating of this in respect to y. Look at it now. We are doing this man, second derivative of this man in respect to y. I'm doing second derivative of this man in respect to y. Then now, doing that, what does it mean? It means that I'm differentiating this man in respect to y. Means that any person that doesn't contain y here, I'm going to have it as what? Constant. And when we differentiate it, it's going to be 0. Look at it. This 8x in respect to y. This 8x does not contain y. Therefore, if I differentiate it, it becomes 0. Plus, look at my plus. This man contains y, and I differentiate it, I will have 3. You remember? When we differentiate y, dy will give me what? 3. Remember, what does it mean? If I have this 3y in respect to y, it simply means 3 is a constant, and since it's a constant and it contains y, you have survived this differentiation. Since this 3 is a constant and it contains y, you have survived this differentiation. I can write this way. You know that I can write this way. This now I can write it this way. Then dy dy will give me what? 1. I will have 3 into what? 1, and that give me what? 3. And that's how we get this 3 here. Are you getting what I'm saying now? The y will give me y. The x dx will give me 1. And the y will give me what? 1. Therefore, if you give me 1 times 3 will give me what? 3. That's how we get that. Then I say that when differentiating this man, he will give me what? 0, because it does not contain y. Differentiating this now will give me 3y. 3, ordinary 3. Therefore, my second derivative of z in respect to what? X, and as well in respect to y, is the answer is what? 3. Then I go to question number what? I. Question number I. Second derivative of z in respect to y. I have to differentiate the function z in respect to y, and I differentiate it again in respect to y again. Look at it. That's what it means. Differentiating. And this differentiation is partial differentiation of z in respect to y. And again, partial differentiation of the result in respect to y again. That's what this means. And that means differentiating the word function z in respect to y. After I have gotten whatever I'm getting for this, I'm going to differentiate it again in respect to y. Then I have it, the first one, which is this in respect to y. And what does it mean? When I say dz dy, means that I'm declaring war onto the function z, and only people that contain y that will what? Survive. I'm declaring war onto the function of z, and only people that contain y that will survive this function. This war. Then look at it. This man can be differentiated this way part. I'm differentiating it part by part. Differentiating this by parts, this. Differentiate plus, look at it. Differentiating this by his own part. Minor, look at it. Differentiating this in his own part. That means I'm differentiating 4x squared in respect to what? Y. Look at it. Plus, look at it, plus. Differentiating 3xy in respect to y. Look at it. Differentiating 2y squared in respect to y. I have it. Then this man will die. Because it doesn't contain y. Look at it. This man will die. Look at 4x squared. It does not contain y. Therefore, when I differentiate it, give me 0. Then this man will survive. That's why it contains x here, but y is there. So he cannot survive because of the word y. And what I'm differentiating here is y, not consign of what? X. This x is only surviving and 3 is only surviving because they contain y. Therefore, I'm going to differentiate this y, and when I differentiate this y in respect to y, it will give me 1. What mean? I said dy. What does it give me? 1. Therefore, dy will give me 1. 1 times 3x will give me what? 3x. Look at it here. Then look at my minus. Then here, it will now be 2 times 2. Give me what? 4. Remove 1 from y will give me what? Y raised to 4. 1. That means 4y. When I differentiate 2y squared, it will give me what? 4y. And that's what I got here. The partial differentiation of z in respect to y is equals to what? 3x minus 4y. Look at what we get here. 0 plus 3x minus 4y. Therefore, that my dz dy in respect to y is 3x minus 4y. Then, I'm going to now mean that partial differentiation of what? Second derivative of z in respect to y is equals to this. And that means I'm going to differentiate this man back again. What does it mean? Come over. I said, I'm going to differentiate this man again for me to have partial differentiation of second derivative of partial differentiation of z in respect to y. Look at here. I'm going to differentiate it again. Differentiating this man again in respect to y. I have 3x minus 4 in respect to y. I'm going to differentiate this separate, that's part by part. I'm differentiating 3x in respect to y, part minus differentiating 4y in respect to y, another part, because this is family, this is another family. Then differentiating this in respect to y, it will give me 0 because it doesn't contain what? Y. As I'm differentiating this in respect to y, and this man doesn't contain y, it's going to give me 0 because it's a constant. Then this man 4y in respect to y will give me 4. Remember? 4y in respect to y will give me 4. Then my answer of what? Second derivative of z in respect to y is equals to minus what? 4. Because this is a minus 4. And somebody will ask, how did I get this? Differentiating to this will give me what? 4. How did I get it? You remember that what? As I said before, look at over here. This man for y in respect to what? Y is same thing as what? 4 outside, because this 4 contain y is a constant. So it survived the what? The destruction. This 4 contain y. Since it contain y, is a constant because 4 is a constant. It doesn't have a change. But it contain y, and we are differentiating in respect to y. I have to come out. I have what? The y and the y. Then this the y will give me 1, and that will give me 4 into 1, and that give me what? 4. And that's how I get this word 4. Are you get what I'm saying? So that's the result of what? Second derivative of z in respect to y. Then let us go to question IV. Question IV said, differentiation of what? Z, partial differentiation of z, which is second derivative of z in respect to y, and as well in respect to what? X. Meaning that I should differentiate this function z in respect to y. After I have done it in respect to y, the result I got in respect to y, I should differentiate that result in respect to x. Get me right? After I have differentiated this man, partial differentiation of this man in respect to y, look at the y is the first one before the second one. As I'm differentiating this man in respect to y, after I have done that, the result I got, I'm going to differentiate that result in respect to x. Look at it here. This is something as this. Differentiating this man in respect to y, the result I got, I differentiate it in respect to x. But, why did I say but? But I have done this before. We have done differentiation of z in respect to y, and we have it to be 3x minus 4y. We have it to have what? We have it to be what? 3x minus 4y. That's what we got before. This function was differentiated in respect to y to have 3x minus 4y. That's what we did here. When we differentiate this in respect to y, look at it, in respect to y, we have 3x minus 4y. And that's a but. Since I have done that, I have to differentiate this man again in respect to x. Look at now. I have done this one. Then the result, I'm going to differentiate it again in respect to x. And that's what I'm doing here. That's differentiation of 3x minus 4y in respect to x. And that will now be what? Partly differentiation of this man. I have to what? Differentiate them in partly. Differentiating what? 3x in respect to x. Minus differentiating 4y in respect to what? X. I'm going to differentiate this, and it's going to be me. Differentiating this will give me 3 minus. Differentiating this will give me 0. Why does it give me 0? It gives me 0 because it doesn't contain x. And since it doesn't contain x, is a constant, I'm differentiating it, give me 0. Therefore, I'm going to have that my what? D, second derivative of what? Z in respect to what? X, and in respect to y to be what? 3 as my what? Answer. To be 3 as my answer. And that's what we have for you today. If you like what we are doing here, subscribe, comment, and share to your friends.